Everyone, today we'll discuss about quantum mechanical scattering and tunneling across a rectangular potential barrier. Here we have drawn the figure. Here we have shown that the particle of mass m of energy is incident on it, and here's the potential barrier of Vx is equal to V naught. This is the second region, and then after tunneling through it, it passes to the region 3. So here we have considered a particle of mass m and total energy E, which has been incident from left to the right direction. Now the probability of entering the particle in the third region by crossing the second region, it's not zero. Okay, and the probability, first of all, you have to see that the probability of entering the particle from region 1 to region 2 also, it's not exactly equal to 0. Okay, because of this, there is a probability of raising the particle from region 2 to region 3 also. Classical mechanically it's not possible, quantum mechanically it is possible, or there is a probability. Now what we know is that if we consider psi 1, psi 2 and psi 3 to be the wave function in the region 1, 2 and 3, okay, respectively. So using the Schrodinger equation for this 3 region, we can write the Schrodinger equation as del square psi 1 by del x square plus 2me by h cross square psi 1 equal to 0. This is for the first region where v is 0, and this one will be del square psi 2 by del x square plus 2me by h cross square minus v naught, obviously, into psi 2 equal to 0. This is for the second region. V naught is for the, in this particular case, v naught, v is 0. And for the third region, again we'll write del square psi 3 by del x square plus 2me by h cross square psi 3 equal to 0. So this is for the third region. Now the solution of this above 3 equation can be written as psi 1 equal to a e to the power I p1x by h cross plus b e to the power minus I p1x, okay, by h cross, obviously. So this will be equation number 4. This is psi 1, obviously. Then psi 2 equal to, again, c e to the power I p2x by h cross plus d e to the power minus I p2x by h cross. This will be equation number 5. Likewise, psi 3 equal to f e to the power I p3x by h cross plus g e to the power minus I p3x by h cross. So this will be equation number 6. Now here A, B, C, D, F and G. This is the constant which has to be determined by the boundary condition. Okay. Now in region, I will talk about the first region. The first term, talking about this particular equation number 4 rather, the first term can be represented by the incident wave and second one is the reflected wave. Similarly in the second region also, but in the third region, okay, we'll talk about the third region. The first term is transmitted wave, okay, and the second term is the reflected wave. So this reflected wave, okay, there is no barrier for the reflection, so second term will be 0. So the solution to this, the equation 6 can be modified and can be written as psi 3 is equal to the power I p3x by h cross. Obviously. So this will be your new equation for the third region. So for evaluating the constant a, b, c, d and f, we have to apply the boundary condition at x equal to 0 and x equal to L. So for this particular thing, what we'll do is that one condition is that psi must be continuous at the boundary. Continuous at the boundary means psi 1 must be psi 2, okay, at x equal to 0. Similarly, psi 2 must be equal to psi 3 at x equal to L. Right? So the other condition is that the let this be, this two condition will be written as equation number 8. Similarly, what will write is the other condition is that del psi by del x has to be continuous. Del psi by del x must be continuous, at the boundary. Therefore we'll write del psi 1 by del x. Okay, we'll write del psi 1 by del x must is equal to del psi 2 by del x, at x equal to obviously say 0, and del psi 2 by del x is equal to del psi 3 by del x at x is equal to L. So again this will be our equation number say 9. Okay, now applying boundary condition to equation number 8 and 9. Okay, 8 boundary condition 8 to equation number 1 and 2. So we'll apply boundary condition 8 to equation number 1 and 2, and we'll get a plus b is equal to c plus d. Okay, and del psi 1 by del x is equal to del psi 2 by del x at x equal to 0. So this is our equation number 10. So this particular thing will give us I p1 by h cross a e to the power I p1 x by h cross minus I p2 by h cross b e to the power minus I p1 x by h cross equal to I p2 by h cross c e to the power I p2 x by h cross minus I p2 by h cross d into e to the power minus I p2 x by h cross. So substituting the values, putting the value x is equal to 0 over here, and rearranging, we'll get p1 into a minus b is equal to p2 into c minus d. So this will be our equation number 11, say. So again further applying boundary condition, the last boundary condition, that is equation boundary condition 9 to again equation number 2 and 7. 2 and 7 will get del psi 2 by del x equal to del psi 3 by del x at x equal to L. Okay, and further if we apply this particular condition, we will get I p2 by h cross c e to the power I p2 L by h cross minus again I p2 by h cross d e to the power minus I p2 again x by h cross is equal to I p3 by h cross f e to the power I p3 x by h cross. So the region 1 and 3 have the same potential, that is 0, and the potential and the value of p1 and p3 is also same. So what we can do is that we'll write p1 equal to p3 equal to under root 2 me by h cross square. Okay, so therefore the above equation may be written as I p2 c e to power I p2a, or rather L by h cross minus I p2 d e to the power minus I p2x by h cross equal to I p1 f e to the power I p1 x by h cross. Again this could be rearranged and could be written like C1. Okay, here we have just to put again just made a slight correction. You have to put L over here, L over here. Okay, so again rearranging this particular equation, we'll get C1 rather I P2 then C1 or the yes, in fact C e to the power I P2a by h cross minus d e to the power L rather L e to the power minus I P2L by h cross is equal to I P1 f e to the power I P1L by h cross, or it could be like C e to the power I P2L by h cross minus d e to the power minus I P2L by h cross is equal to P1 by P2. Okay, F e to the power I P1 L by H cross. So this will be our equation number say 11. Okay, now psi 2 is equal to psi 3 at x is equal to L. So this thing will give us C e to the power I P1 L by H cross plus D e to the power minus I P2L by H cross is equal to F e to the power I P1L by H cross. So this will be equation number 12. Okay, so from equation the above equation solving, we'll get A is equal to P1 plus P2 by 2P1 into C plus P1 minus P2 by 2P1 into D. This will be equation number 13. Obviously again we'll further have to solve this equation, and we'll have to calculate B also, as we have done in the case of A. So B will be equal to P1 minus P2 by 2P1 into C plus P1 plus P2 by 2P1 into D. So this will be equation number say 14. So we have found out the value of A and B with respect to P1 and P2 and also C and D. Next, and the next lecture will proceed further. We'll continue the same topic rather. Until then, thank you very much.